Hey guys, Mr. Zigner. We're going to be taking a look at reflections today. Reflection is one of the types of transformations. A reflection, you may have heard the word flip. There were slides, flips, and turns back when you were a little bit younger. Well, the reflection is the flip. Okay, that's a transformation in which the figure is reflected in a line called the line of reflection. So here we have our quadrilateral. It is flipped over, kind of like it's looking at itself in the mirror, and the line of reflection would be that mirror. So it flips over, and all the 4 points here are all the same distance to the line on this side. So this point, if we got a ruler out and measured how far apart the line and this point are, well, this point and the line would be the same distance apart. Okay, so here we go. Tell whether the blue figure is a reflection of the red figure. Well, you can see that this red figure was flipped over to form the blue figure. So yeah, that is a reflection. Here, that's not a flip. That was more of a translation. That's just slid over. So let's see what it says here. If the red figure were flipped, it would point to the left. Right. See how the red figure here is pointing towards the line? Well, if this were properly flipped, the blue figure would also be pointing towards the line. I think of looking at myself in the mirror. My reflection is looking back at me. So if this point is pointing towards our line of reflection, then the image created would also be pointing towards that line of reflection. Hope that makes sense. Okay, a few more examples. Tell whether the blue figure is a reflection of the red figure and explain. Try to stay ahead of me. See if you can guess yes or no on each one of these as I go through them. What about number one? Is that a reflection? The answer is no. No, this is another translation. This, let's see, is the blue a reflection of the red? Right. So this was, again, just slid down here. So that's just a translation. What about number two? Is that a reflection? Once again, no, that's another translation. It is just slid across the line. It wasn't flipped over. What about number three? And look at that, they even put it at an angle. Is that a reflection? You almost need to tilt your head a little bit there to see that. And if you do, you can see that, yes, this one is definitely flipped over the line and the same distance from the line, even though the line is drawn at an angle. So there, number three is the only one that is. So here's a follow-up question. Which one of these pictures is not the reflection? So all of them are good reflections except which one? Can you find it? I'll give you a second. Did you find it? Turns out the one that's not a reflection is right here. Sure, that's the only one that is a translation. Here the hats are pointing in towards each other. Here they're pointing away from each other. Here they're both turned the same way and again flipped over. So yep, that's the only one that's not a reflection. Now it gets a little more technical here. And this is when you want to start reflecting over the y-axis or reflecting over the x-axis. There are a couple rules to follow, but here they are. To reflect over the x-axis, take the opposite of the y-coordinate. Okay, so I'm going to come down here. So again, if you're reflecting over the x-axis, if your ordered pair is xy, make up a number 2, 3, then the new point would be 2, -3. Let me write that down so you can see it. So if the one point is 2, 3, and you want to reflect it across the x-axis, the new point would be at 2, -3. You see that rule? Xy becomes x opposite of y. Okay. Here in blue, to reflect over the y-axis, and now we're going this way, over the y-axis, you take the opposite of the x-coordinate. So again, if you have 2, 3, if you want to reflect this in the y-axis, 2, 3 becomes opposite of 2, which is -2, 3. There we go. So that's how you create the new ordered pair. For instance, let me just take the original point A here is at -3, 1, -3, 1. So if we reflect across the y-axis, okay, that means I use the opposite of the x and then keep the y the same. So the opposite of -3 would be 3 and keep the y the same. So that's 1. And now is this point 3, 1? 1, 2, 3, 1. See there, perfect, it works. Now, what if I want to go over the x-axis from that same 3, 1 right here, making this point? Well, again, so 3, 1, I'm sorry, negative 3, 1, negative 3, 1. You keep the x the same, but you change to the opposite of the y. So negative 3, 1 would become, again, keep the x the same, but make the y the opposite. So the opposite of 1 would be negative 1. Now, is this a prime right here at negative 3, negative 1? Negative 1, 2, 3, negative 1. Perfect. So that's a little rule, and that's a great one to write down. And you'll be using, my students, you'll be using that on some of the worksheets we'll be doing. So, and I have that image for some of my other slides, but it's a great one to write down if you want to pause the video for a second. Okay. So back to some practice problems. Tell whether one figure is a reflection of the other figure. Okay. Is this one? Yes or no? What do you think? Nope. No, that would have been flipped over. This 3 would have been sort of backwards. I don't even think I could draw a backwards 3. I might have trouble with that, but it is not flipped over. This was just slid over. Oh, kind of like the 4 here. Now, this one is a yes. Yep, that's a reflection, because while this 4 is, if you tilt your head again, this 4 is backwards compared to this one. So, yep, it was flipped over to create the other 4 across this line of reflection. Okay, here we go. We're going to draw some of these. All right, draw the figure and its reflection in the x-axis. Identify the coordinates of the image. All right, I brought the rule over here just to help us. So let's see here. K is at negative 3, 3. 1, 2, 3, 1, 2, 3. There's K. L is at negative 2, 1. So 2 to the left and up 1. That's L. M is at 1, 2. So 1 to the right, up 2. And N is at 2, 5. So 2 to the right and up 5. 1, 2, 3, 4, 5. There's N. Okay, so there's our figure. We're going to reflect it. I guess I can draw these lines. They're not going to be perfect. I want this video to last forever. All right, so now we're going to reflect across the x-axis. So that's this rule right here. To reflect across the x-axis, all of our ordered pairs become, well, the same x, but the opposite of y. The same x, but the opposite of y. Okay, so to get this new k prime, the same x, but the opposite of y. So that would be negative 3, negative 3. So 3 to the left and down 3. There's my k prime. L prime, well, keep the x and change the y to the opposite. So that would be negative 2, negative 1. So negative 2, negative 1. There's L prime. Connect those. M1, 2 would become, again, I don't know if you can still see it under my picture here, xy becomes x opposite of y. All righty. So M was 1, 2. So M prime would be 1, negative 2. 1 to the right, down 2. So there's M prime. I'm not drawing my lines very nicely there. I apologize. And N prime, again, keep the x and find the opposite of the y. So 2, negative 5. So 2, negative 1, 2, 3, 4, 5. So there's my N prime. Now, I know what some of you might be thinking. Wouldn't it be easier, instead of all that opposite of a certain variable, like just do something like this? Hey, M is 2 above the x-axis, so M prime would be 2 below the x-axis. L is 1 above the x-axis, so L prime is 1 below. See what I'm doing? K is 3 above right here, so K prime would be 3 below, and N is 1, 2, 3, 4, 5 above, so shouldn't this be 5 below? And the answer is yes, absolutely. That's exactly how you could do that. But what if they didn't give us the graph paper and they just said, hey, here are the points? Where would their ordered pairs be if you reflected across the x-axis? So now you have to kind of know the rule. And so L prime, remember how it works, is across the x-axis. You keep the x the same, but you change the y to the opposite. So 1 becomes negative 1. So I really wanted you to be aware of that rule. But yeah, if you had graph paper, sure, you could plot the points and then just figure out how to flip over all those points to get its mirror image across that reflected line of, in this case, the x-axis. Okay, now we're reflecting this figure across the y-axis. Okay, so we start with 2, -3, 2, -3. Oop, I'm going to have to slide down a little bit. Okay, so what was that? 2, -3. So 1, 2, 1, 2, 3. That's our B. I better write that B. 3, 1 is C. So 1, 2, 3, 1. There's C. D is at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. There's D. And E is at 3, 0. 1, 2, 3, 0. Wow, this is a crazy shape. I'm not going to draw it very well. Do not have my straight line tool out. That's like a skinny, weird looking quadrilateral. Okay. Now we're reflecting across the y-axis. Let me double check. We are doing y, right? Yes, y-axis. So again, you could kind of just say, oh, hey, B is 2 to the right of the y-axis. So B prime would be 2 to the left of the y-axis. But I'd rather not do it that way, just again, in case we didn't have graph paper, so we can think through it using this rule. Now, this time, xy becomes opposite of xy. So this time, again, if you're going across the y-axis, guess what changes? The x. Did you catch that? When you reflect across the y, you change the x. And when you reflect across the x, you change the y. Kind of a neat way to remember that. All right, so let me slide down so we can see that rule. So again, reflecting across the y-axis, so we're changing the x. So B prime changed the x. So it'd be -2, -3. And I believe that's where I put it, -2, -3. Perfect. So C prime, okay, so now we change the x to go across the y-axis. So that'd be -3, 1. So C would be -3, 1. And perfect. Looks like it's right across that y-axis from it. There's C prime. D prime, looks like a little apostrophe there. So 5, 3 becomes -5, 3. So -5, 1, 2, 3, 4, 5, 1, 2, 3. There's D prime. Does that look like it's across? Yep, perfect. Across the y-axis. And E prime was 3, 0. So now it'd be -3, 0. So 1, 2, 3, and 0 stays right there. So that would have been E prime. And then again, try to connect these, but it was pretty crazy. And I'm being a little lazy and not getting out my straight line tool. Hope you can forgive me for that one. So again, it doesn't look very nice, but nonetheless, those are all the reflected points in their correct place. But again, if you don't have graph paper, it's really nice to be able to use this little trick. So reflecting across the x-axis, you need to change the y-coordinate. If you reflect across the y-axis, you need to change the x-coordinate. And you've got the point in the exact right spot where it's supposed to be. All right, so I'm going to move myself down here out of the way. The coordinates of a point and its image are given. Is the reflection in the x-axis or y-axis? So 0, 3 became 0, -3. So what changed? Well, 0 stayed 0, so the x stayed the same. 3 became -3. So the y changed. You remember the rule in the last slide? If the y changes, that means we must have reflected across the x-axis. Here, I'll show you right up here. Reflecting across the x-axis, let's see if I'm right. xy becomes x opposite of y. So x opposite of y. So here was the original xy, and then it became x opposite of y. 3 became -3. Okay, so I'm guessing this is the other one. So now 1, 5 becomes -1, 5. Yeah, what changed? The only thing that changed was the x-coordinate. The y stayed the same. So what is that? Let's see, xy becomes opposite of xy. So we clearly reflected across the y-axis. Again, when the x changes, you must be reflecting across the y. When the x change, I'm sorry, when the y changes, you must have reflected across the x. And here, the x change, so you reflect across the y. That rule's right here. So whichever axis you're reflecting across, the opposite letter coordinate is what you're changing to create the new ordered pair. Okay, reflect the triangle in the x-axis, then reflect it in the y-axis. Graph the resulting triangle. All right, so again, we could go with this, but let me try drawing it. Let's do one way and one the other way, meaning I think I'll just count how many spaces I have to move the triangle for the first reflection, but then I'm going to try to use the rule down here to do the second reflection, just to show you there's two different ways to do it. Okay, so k is 2 above the -3, so k prime would need to be 2 below the -3. J is 2 above right here, so J prime would have to be 2 below, so that's J prime. Okay, and this was K prime. Again, that first image is called prime. L is 4 above the -3, so L prime has to be 4 below. 1, 2, 3, 4. There's L prime. See if I can draw this one, make it not look too bad. There we go. So we're reflected across the x-axis. Okay, now we're supposed to reflect across the y-axis. Alrighty, so now let's try to use the rule. Okay, so we do these in order, J, K, L. Well, J prime is at -4, -2. -4, -2. That's kind of sloppy. So let's J prime. So now we're going to make J double prime. So we're going to flip it again. So, but this time across the y-axis. So what's the rule when we go across the y-axis? So now this is our line of reflection. Well, the xy becomes opposite of xy. All right, so you know what? I'm going to move this right here, right below it. That's a better place to be. So again, xy across the y-axis becomes opposite of xy. So we have to change this number. The -4 becomes +4, and the y stays the same. All right, so that's how I find the new ordered pair. So it's 4. Oh, I'm sorry, that was a -2. So it stays a -2. My bad. So again, the x becomes the opposite. The y was a -2, so it has to stay a -2. My bad. Made a little mistake there. So 4, -2. There we go. There's J double prime. K prime, let's see, K prime is at -3, -2. K double prime. Now again, across the y-axis, xy becomes opposite xy. So this -3 becomes a +3, and the -2 stays the same. So 3, -2. There's K double prime. L double prime. I'm sorry, L prime first, before we get L double prime. L prime is at -3, -4, -3, -4. And again, reflecting across the y, we have to change the x. So that becomes 3, -4. So 3, -4. And there's L prime. Connect those. And now just sort of sit back and look. Does that look like a good reflection? Sure it does. Well, I could have drawn the lines better, but it is a proper reflection of this JKL prime to make JKL double prime. All righty. Oh, and that brings us to the end of our time for reflections. If you enjoyed the video, like, comment, subscribe before you head on out. Thanks a lot, guys, and we'll see you next time. Bye-bye now.